This video is covering mean absolute deviation. The objective with this PowerPoint is to find and interpret the mean absolute deviation for a set of data. The prior knowledge that you need to have in order to calculate mean absolute deviation is calculating a mean or an average. And you just add all the numbers together and divide by the amount of numbers that went into making your sum. Mean absolute deviation is the average distance between each data value and the mean. We have two different types of measures when we are calculating with data. We have measures of center, which are mean and median, and we have measures of variability, which are range and mean absolute deviation. The measures of center tell us a general tendency in the data, where the measures of variability talk about the range or the spread of the data, how far apart the data values are versus how close together the data values are. With mean absolute deviation, it's very similar to range. The bigger the mean absolute deviation, the more variation, or the farther the numbers are spread apart. Whereas the smaller the mean absolute deviation, the smaller the variation, because the numbers are closer together. When you're calculating a mean absolute deviation, you first have to find the mean, and the mean is just the average, where you add the numbers together and divide by the total amount of numbers that went into making your sum. You then find the distance between each data value and the mean. And then you find the average of the differences. But we did state that when you calculate with those differences, you must use the positive values of the differences. You would have had to take the absolute value of the differences. So you're going to subtract the mean from each value, and the result is called the deviation from the mean, or how we move away from the mean. So the first example is to find the mean of the number of cell phone contacts stored in 8 friends' phones. In order to do so, you'll add together your data values of 52, 48, 60, 55, 59, 54, 58, and 62. When you do, you come up with a mean of 56. You would have gotten your sum and divided by 8 to get 56. The number line you see here talks about the deviation from the mean. If you notice, the mean is here in the center, and the deviation is the track towards the x's, and the x's are the data values. So if we left the mean of 56 and went 2 spaces to the right, we would be at this data value. So that would be represented by 56 plus 2, which tells us this data value was 58. If we left the mean and went 3 to the right, we would get to this data value. So we would say 56 plus 3, which is 59. So this data value would be 59. If we left the mean and went 4 to the right, we would be at this data value, which would be 56 plus 4, which means this data value was 60. And if we left the mean and went 6 to the right, that would mean that we have 56 plus 6, which is 62. The same thing works for the negative side of our mean. So the numbers moving to the left would be subtracted from the mean. So if we left the mean and moved 1 to the left, we would reach this data value. So that means that we are doing 56 minus 1, which means that this data value is 55. If we left our mean and went 2 to the left, that means that we would take 56 and subtract 2, which leaves us at 54. If we left our mean and went 4 to the left, that would be 56 minus 4, which means that this data value was 52. And if we left our mean and went 8 to the left, that would be 56 minus 8, which leaves us at 48. So by using the deviation and this number line, we were able to recreate the data set. This is not typically how we would see the information presented. We would be asked to find the deviation. So in doing so, we take each data value and we subtract the mean from it. So our data values again were 48, 52, 54, 55, 58, 59, 60, and 62. So if we were looking to get the deviations, we would subtract the mean from it, which would be 48 minus 56, which is negative 8, 52 minus 56, which is negative 4, 54 minus 56 is negative 2, 55 minus 56 is negative 1, 58 minus 56 is positive 2, 59 minus 56 is positive 3, 60 minus 56 is 4, and 62 minus 56 is 6. Notice with these deviations we have positives and we have negatives, whereas on our number line we only had positive values. Because when we look at the number negative 8, that is telling us that we will be 8 spaces to the left of the mean. Whereas if we looked at the data value of 62, that deviation was 6, and it was positive, meaning that 62 is 6 spaces to the right of the mean. So when we are talking about the deviations, we are talking about their positive values because the positive and the negative tell us the direction in relationship to the mean. If we were to now continue and find the mean absolute deviation, we're now going to take the mean of the deviations. And again, we use their positive values. So negative 8 would be 8. Negative 4 would be 4, negative 2 would be 2, negative 1 would be 1, 2 would be 2, 3 would be 3, 4 would be 4, and 6 would be 6. Now you have to find the mean of these numbers. When you add all of the positive values of the deviations, you come up with a sum of 30. If you divide that by the 8 numbers that created that 30, then you would have a mean absolute deviation of 3.75. That means that on average, each data point changes from the mean by about 3.75 spaces. That is the average deviation from the mean. In our next example, we will be interpreting the mean absolute deviation to talk about the variation of two different sets of data that are related. Our baseball example says the top 5 salaries and the bottom 5 salaries for the 2010 New York Yankees are shown in the table below. Salaries are in millions of dollars and are rounded to the nearest hundredth. So the top 5 salaries were $33,000,000, $24,290,000, $22,600,000, $20,630,000, $16,500,000. The bottom 5 salaries never reached the millions. We have $450,000, $440,000, $430,000, $410,000, and $410,000. So we're looking at two different sets of data, and the first thing that we need to do is to find the mean absolute deviation for each set of data, and we're supposed to round to the nearest hundredth. As we start to analyze this data, we have to realize that we have two sets of data. First for the top 5 salaries, secondly for the bottom 5 salaries. And the very first step that we have to do when calculating the mean absolute deviation is to first find the mean. So when you add the top 5 salaries together, you get 117.02. And you divide that by 5, leaving you with a mean of 23.4. So we're then going to take all of our data points and subtract the mean from it. So 33 minus 23.4. 24.29 minus 23.4. 22.6 minus 23.4. 20.63 minus 23.4, as well as 16.5 minus 23.4. We know that we're going to have to take the positive values of whatever our differences are, so we're saying that we're going to find the absolute value of each difference. So putting absolute value bars around each of these subtraction problems tells us that whatever we get as our answer, we will take the positive value. When we do 33 minus 23.4, we come up with 9.6. So our answer will be positive 9.6. When we do 24.29 minus 23.4, we come up with positive 0.89. So we will keep our value as positive 0.89 since we're taking the absolute value. When we do 22.6 minus 23.4, we come up with negative 0.8. But because we are taking the absolute value, our answer would be positive 0.8. We then do 20.63 minus 23.4, which leaves us with negative 2.77. Because we are taking the absolute value, we will write down positive 2.77 as our answer. And we'll do the same thing for 16.5 minus 23.4, and we come up with negative 6.9. And because we're taking the absolute value, our answer will be positive 6.9. Now to get the mean absolute deviation, we would take the mean of these numbers by adding 9.6 and 0.89 and 0.8 and 2.77 and 6.9, leaving us a sum of 20.96. We'll divide it by our count, which is 5. And when you divide by 5, we are left with 4.192. So if that is rounded to the hundredths, that would leave us with 4.19 as our mean absolute deviation. Now that we've done this for the top 5 salaries, we'll do the same thing for the bottom 5 salaries. Once you complete the calculations for the bottom 5, you find that the mean is 0.43. So you will subtract each data value by 0.43, resulting in the differences of 0.02, 0.01, 0, 0.02, and 0.02. Again, the 0.02s at the bottom when you do the subtraction, will come up negative. But we have to take the absolute value because distance is not negative. You can have distance to the right or distance to the left, which is indicated by the sign. But the distance itself is neither positive nor negative. So we take the absolute value. When you get their average, you come up with a sum of 0.07. You divide by 5, and you leave a rounded mean absolute deviation of 0.01 because we've asked you to round to the hundredths. The next part of the question asks you to write a few sentences comparing their variation. If you're going to compare their variation, you're going to be comparing the mean absolute deviation because that is a measure of variation. Because 4.19 is greater than 0.01, we would say that the top 5 salaries are more spread apart than the bottom 5 salaries. Or we may say that the bottom 5 salaries are much closer together because 0.01 is a very small mean absolute deviation. So again, when we're talking about variation, we are talking about the spread of the numbers. And the range and the mean absolute deviation should go hand in hand. If the mean absolute deviation for the top 5 salaries is larger, then the range should be as well. So if we found the range of the top 5, then that means that we would take 33 and subtract 16.5. And when we do, we come up with 16.5. If we were to take the range of the bottom 5, we would take 0.45 and subtract 0.41, and that is 0.04. And this helps to support our conclusion that the variation of the bottom 5 salaries is much smaller and the numbers are much closer together.